Hello everyone. So before going to the main experiment, we need to clear some of our concept. So first of all, take this table as a example. So it has three inputs and one outputs. So as it has three inputs, so we have eight combination. So if you represent this input binary numbers into decimal representation, then we can find that this is 0, 1, 2, 3, 4, 5, 6, and 7. And this is actually the min term. So if you write this expression in the dot form or and form like that a and b and c, then each of this one is called min terms. Like this is all are 0, right? That's why we write it a bar, b bar, and c bar. And wherever there is 1, this for this case, this is a is 0, b is 1, c is 1. So this is a bar and b and c. And we can express this min term also like this: m0, m1, m2, m3, m4, m5, m6, and m7. Please remember these are in small m. And from this truth table we can write the function like this. So f is equal to this one plus or this one, this one, this one, and this one, because only for this case the output function is true. So we can write it like this: a b c, a bar b bar c plus a bar b c plus a b bar c bar plus this one a b c bar plus this one abc. So right now we have 1 2 3 4 5, and here is also 5. Okay, so this is actually our function, and we call it sum of product. You can like sum of product, also known as SOP. You can see each of the min terms are in AND form, and all the min terms are connected with a plus sign. So these are product form and this is plus form. So all together is sum of product. Okay, another thing, we can write this simple thing with you can see this is actually m1, right? So this is m1, then m3, then m4, m5, and last one is m7. So we can write this function also like this: if, as it has three inputs, so a, b, and c, comma, is equal to, this is m1 plus m3 plus m4 plus m5 plus m7. And another way is, as it is a summation, you can use the summation sign, and for min terms small m, and only with 1, 3, 4, 5, and 7. So now another concept is, as this is a very big function, right? So it's better to make it small. So there is a way to make it or make your expression more short. We can use the K-map formula. To make the K-map, first of all, you have to, as there is 8 combination, you have to make a box of 8 like this. Okay. Please remember that in the bottom part you have to take the MSB. You can also vice versa it, but to for best practice you can use in this format. Here is the MSB and here it will be the LSB. So our case MSB is A. So I will put A over here and BC in this direction. Okay. Now you have to start with the 0. So for this case, as there is only one variable, so you can put 0 and 1 over here. So this is A bar and this is A. And for this case, you have to think 0 0 0 1 1 0 1 1. In the K-map, you cannot change two variable at the same time. Like from here to here, only a single variable is changed. For this case, if it is the C, here C is only changed. But if you put this one over here, then you have to change the both variables. That's why from the K-map we are doing that like that. We put 1 0 in this column and 1 1 in this column. So for this case, this is BC bar, this is BC, this has bar, this is BC and this is BC bar. Now if you put the min term over here, so it will be like 0 0 0, so 0 0 0, this is M0. So M0 is over here, so 0 0 1 0 0 1 is M1. So this is M2 and this is M3. Now from here it will come 1 0 0 1 0 0, which is M4, M4, M5, M6, M7. Okay, now you have to put the output over here. So our M0 is 0, then M1 is 1, then this is 0, then again it is 1, and for M4 1 1 0 1 1 1 0 1. So the next step of K-map is form a group, and you can form a group like in this way. So 2 4 8 16, and you have to find the largest group among the output. So here the largest group is this one. And this, you can see you have to cover all the ones. So this one is now empty, so it also need to make a group. So we can make these two as a group, and it is okay to make this one common in both groups, so it is completely okay. So now if we make the function like from this group, you have to find which variable is changed. So here, if you consider this box, you can see in this box a bar and a both are changed. So in this and this, a is changing, and here you can see that b bar and b, this one c is not changing, c is constant, so c is not changing, so b bar is changing. So from this group we will only take that variable which is not changing its states. So c is not changing in this box, so we will collect c from that group. And next we will move to the next group. So we will add a plus over here, then we will come to this group. Now in this group you can see that a is fixed, and from these two b bar is fixed, so c is changing, so c changes its states in this group. So we will remove the c, we will take the b bar. So from here a, and from here b bar. So this is our final circuit. You can see initially we get this function, but with using the k-map we make it much more simpler. Now if you represent this expression in this symbol, we can find that we have a, okay, and a and b bar is AND, so we need an AND gate over here. B should go to a NOT gate, so b is here. Now if you connect this like this, okay, so a b bar, and another one is a OR gate, and c is coming from there. So this is our F, and this is our final circuit. And if you need to check the cost of this circuit, so the cost of a logic circuit is, so number of inputs, so we have there 1, 2, 3, 4, 5, so we have 5 inputs. Okay, and the number of gates, so we have 1, 2, 3. So total is 8, and this is the cost of a logic circuit. So in this lesson we came to know about the mean terms, then SOP, sum of products, K-maps, and how to write this function in mean term. And cost of a logic circuit. So in the next part we'll talk about more about the K-maps.